Okay, so with 5-7, we are now, a lot of areas of math do this anyway. We are just continuing to build on what we've already done. So even thinking in 5-5, so what we did earlier this week, we looked at factoring polynomials so that we could solve polynomial equations by factoring. Factoring isn't a method, or the factoring techniques we have don't work for every polynomial necessarily. So what these sections are getting into, starting with yesterday in 5-6, we looked at how can we use synthetic division to factor a polynomial, because then eventually we'll use that to solve. And that's where 5-7 and 5-8 are getting into as well. This is really looking at determining how many roots or solutions should an equation have, and then how to find those. So we're really just continuing to build. The examples we're going to go through today are really not new techniques at all. We're just building on what you've already done. So this front side is just information. I'm going to kind of pull out the information you really need to focus on here, but this is about determining the number and type of roots or solutions a polynomial equation has. So it has at the top, this is reviewing some vocabulary. So recalling what the zero of a function is. So if you're asked to find the zeros, you know what that means. A zero of a function, f of x, is any value c such that f of c is equal to 0. So c is an x value. So a 0 is any x value where when you substitute it into a function, the y value is 0. So we have talked about zeros before. So then also recall that when a function is graphed, the real zeros of the function are the x-intercepts of the graph. And that's only the real zeros. There might be imaginary zeros. Obviously, those don't show up on the graph, but we still have methods we can find them. So in Chapter 4, we had spent one lesson talking about 4 different terms: roots, solutions, zeros, and x-intercepts, and how they were all related. This ties that together now with polynomials, but also shows how factors fit into it. Because again, the whole idea is we're eventually using the zeros or the solutions or the synthetic division that we have to find the factors so that we can solve. So it says let p of x be a polynomial function. This is just the general form for a polynomial function. The following 4 statements are equivalent. So I'm going to highlight 2 of them just because I want to draw your attention to those 2. So if c is a 0 of p of x, and again, c is an x value, then we can also say c is a root or a solution of the related equation. But we can then say x minus c is a factor of the polynomial. So notice an x minus c would typically, if it was written as a factor, would be in parentheses. So if x equals c is a 0 or a solution of the equation, then x minus c is a factor. So it's kind of relating the solution with the factored form. And then if c is a real number, the ordered pair c0 would be an x-intercept of the graph as well. So I'm just drawing your attention to that relationship between if you know something is a 0, then we know what the factor is, or vice versa. If we know the factor, we know a 0. And then it just gives a specific example, so an actual polynomial, not just a formula. So for this polynomial, it's giving us that the zeros of that polynomial are -3, -2, 1, and 2. So then those 4 numbers are also the roots of the equation, or the solutions of the equation. But then take a look at what the factors are. So it gives the factors as well, meaning we could write it in factored form. So if x equals -3 is a 0, then notice x plus 3 is a factor. If x equals -2 is a 0, x plus 2 is a factor. If x equals positive 1 is a 0, x minus 1 is a factor, and if x equals positive 2 is a 0, x minus 2 is a factor. So in the factored form, the sign is the opposite, because then you set it equal to 0, do the opposite operation to get the solution. And then it also shows the graph. Those four numbers also are the four x-intercepts on the graph. Okay, so a big part of really understanding the math is knowing the vocabulary, knowing what things mean. So it's important to see how all of these are related. Zeros, roots, solutions, x-intercepts really all mean the same thing. And then it's tying in how the factors are related as well. And then what is written below really, I'm going to read through this information with you. The very bottom is the key part of it. And I have already talked about this. This is now formally defined. But it says when you solve a polynomial equation with a degree greater than 0, there may be one or more real roots or no real roots. So the roots could be imaginary numbers. Since real numbers and imaginary numbers both belong to the set of complex numbers, all polynomial equations with a degree greater than 0 will have at least one root in the set of complex numbers, and this is the fundamental theorem of algebra. Okay, if something is the fundamental theorem of a subject, it's probably important. But this is basically saying, and I have it just below, so any polynomial equation you solve, if the degree is greater than 0, then it will have at least one root or one solution in the set of complex numbers. Now, to me, the more important piece is what's called the corollary to that fundamental theorem. This is really what I want you to know, that a polynomial equation of degree n has exactly n roots in the set of complex numbers, including repeated roots. This is the idea I've already talked about with you. 2 lessons ago when we were solving equations, I said find the degree of the polynomial because that's how many solutions you should have. That's what this says, and it's all based off of that fundamental theorem. So if the degree is 3, you should be getting 3 solutions when you solve the equations. The degree is 4, 4 solutions, and so on. So knowing that before you start solving the equation, I should be getting 5 answers. And then if you don't get 5, something isn't right. You're missing something. It's important to have that understanding. So we are going to go through the first 4 examples. It's all under example 1. And it's just solving these 4 equations. But then additionally, I want you to state the number and type of solutions that you have. So none of this is new. All 4 of these equations, you have already solved equations like this. You've used techniques already that we're going to use here to solve these. It's now just kind of putting them all together. And ideally, where you want to get to is you want to be able to look at an equation and say, okay, this technique is what I should use to solve it. This is how I solve this type of equation, or this is something I could try. And if it fails, what else could I try? So if we look at part A, first of all, just looking at that equation, how many solutions should we have? 2. The degree is 2, so in the end, I should have 2 solutions. If I don't have 2, something's wrong. So just be thinking about that from this point forward. Anytime we're solving, how many solutions should I get in the end? And that's a way to double check your answer. So I have x squared plus 2x minus 48 equals 0. How would I solve that? You've solved equations like that before. What method could you use to solve it? The what? The diamond or factoring. So this is a quadratic equation. Factoring is a method that could possibly work. The diamond will allow you to see if it will work. So if we're setting up a diamond, what are we multiplying to? Negative 48 and adding to 2. Are there 2 numbers that work? -8 and -6. Okay, so Say this didn't work though. Say I couldn't find two numbers that actually worked. Factoring doesn't work. What's another method you could use to solve that? Because factoring isn't the only method that could be used. Quadratic formula would work. So it's a quadratic equation. Factoring sometimes works. It's probably faster than the quadratic formula when it does work. If it doesn't work, quadratic formula always works. Or completing the square was another method, but that's not as popular of a method to be used frequently. So then to factor this, since the a value is 1, I can just go straight to my two factors, x plus 8 times x minus 6 equals 0. And then once it's factored and equal to 0, I can set each factor equal to 0 to solve for x. So x plus 8 equals 0. X minus 6 equals 0, and solve. So the first one, subtract 8, x is negative 8, or second one, add 6, x is positive 6. Okay, so I said at the beginning I should be getting two solutions. I did, so I know the number of solutions is correct. I could substitute them both in to actually check that they themselves are correct. But then when it says state the number and type of roots, at the end, all I'm looking for you to state, just to start getting this in your mind, is how many solutions you have that are real and imaginary. So I did get two solutions. They are both real numbers. So I'm just going to say I have two real solutions. Okay, any questions on A? Okay, then if you look at the equation in B, x cubed plus 2x equals 0, how could we solve this equation, or what could we try? Any ideas? Okay, so that would stick out to me first right away as well, because I see x cubed, and you have formulas for factoring a sum or difference of cubes, so that I would check for that. I know x cubed is a perfect cube, but is 2x a perfect cube? No. Okay, so it's okay to think of something and have that not be the right thing. At least you're thinking, okay, I could try this, oh, it doesn't work. So this is not a sum of cubes. If this was a perfect cube, that is what I would do. But 2x doesn't work. Find a GCF. What do these two terms have in common? An x. Okay, so I could factor out an x, and I'm left with x squared plus 2. But at least now I have a factored form, and I can set both factors equal to 0x. That GCF is its own factor. So I can set x equal to 0 or x squared plus 2 equal to 0, and then solve them both. The first one, x equals 0, that's already solved, so 0 is an answer. The second equation, how do we solve for x? Subtract 2. So x squared equals negative 2, and then square roots each side, and x equals, how would we write? Yep, it's going to be imaginary, square root of a negative, so it'll be I square root 2. How many solutions should we have? 3. What was that? Yes, so notice this is kind of your check. I need 3 answers. Right now I only have 2. I forgot in the second one, when I take the square root, I have a positive or a negative. That's now giving me 3 solutions. So I have plus or minus I root 2 or x equals 0. Those are my three solutions. So then to state the number in type, I'm stating how many real, how many imaginary. So I have 1 real and 2 imaginary solutions. And it's just your way to double check, did you actually end up with the correct number? We needed 3, we ended up with 3. Your imaginary solutions, we'll be talking about this idea more and more. Imaginary solutions will always occur in pairs. So you'll never just have an odd number of imaginary solutions. It'll always be either 2 imaginary solutions or 4 or 6. They always occur in pairs because they occur when you take the square root of a negative, and that always includes the plus or minus. All right, so looking at C, all 4 of these examples are a little bit different. All methods you've used before, but all different from each other. So in C, we have y to the 4th minus 256 equals 0. How many answers should we be getting? 4. Now, looking at this, we cannot solve this by adding 256 to both sides and then taking the 4th root. If we did that, we're not going to get all 4 of our answers. We're only going to get 2. So I'm going to take that method or that technique of solving for y off the table. We can't add 256 and take the 4th root. Other ideas and methods that you know that we could use to solve this. They are perfect squares. So yes, 2 terms with factoring. If there isn't a GCF, have in mind difference of squares, difference or sum of cubes, and y to the 4th and 256 are both perfect squares. So this is a difference of squares, meaning we need to find the square root of both terms. So what's the square root of y to the 4th? Be y to what power? Squared, yep. Square root, divide the power by 2. And then the square root of 256 is 16. Okay, so the formula for factoring a difference of squares is a plus b times a minus b. Y squared is our a, 16 is our b. So it would be y squared plus 16 times y squared minus 16, or if you had those flipped, it's fine. As long as you have both, it doesn't just become y squared minus 16. You still need the y squared plus 16. But now I can set each of those equal to 0 to solve for y. So y squared plus 16 equals 0, y squared minus 16 equals 0. So in the first one, if I want to solve for y, I can subtract 16 from each side. So y squared equals negative 16. Take the square root. And I get y is equal to 4i, and I need the plus or minus 4i. So 4i because it's an imaginary number with a negative 16 in there. And for the second one, I can add 16 to each side. Y squared equals positive 16. Take the square root of each side, and y is equal to plus or minus 4. So I said I should have 4 answers, and I do. Positive and negative 4i, positive and negative 4. And that means I have 2 real and 2 imaginary solutions. Questions on C? All right, and then the last one, D. Looking at that equation, what method or technique could you use or try to solve for x? What? the synthetic division. We could. We're not quite there to know what to try yet with the synthetic division, but I heard grouping yet. Heard a few people say that. So yes, eventually that's where we're headed. Actually, in the second part of 5.7 and in 5.8, we are going to be using these techniques along with synthetic division to factor. But this one with 4 terms, we actually can try grouping, see if that works alone. So with grouping, first 2 terms, what do they have in common? X squared. Factor that out, we have 3x minus 1. And then second 2 terms, what do they have in common? 3, so take out a 3. Dividing both by 3, we have 3x minus 1. And for grouping to work, parentheses have to be the same, which they are in this case. So fully factored, we have 3x minus 1 times x squared plus 3. And then we can set each of those equal to 0 to solve for x. So 3x minus 1 equals 0, or x squared plus 3 equals 0. For the first one, to solve for x, we would add 1 to each side, so 3x equals 1. Divide by 3, so x is positive 1/3. Leave that as a fraction, don't write 0.3 repeating. And then second equation, solve for x, subtract 3 from each side. Take the square root. And we get x equals plus or minus, how would we write that? I square root 3, yep. And we should have 3 solutions, which we do. We have 1 real, 2 imaginary. Okay, so any questions? Like these methods we just covered, they're not new. You have all the techniques. It's just now kind of putting them all together, you seeing an equation, and I'm not telling you what to use to solve it, but you have to know what methods will work or what methods you can try. It's okay if you try something, it doesn't work, and you have to try something else, as long as you know what to try, or you're learning what to try. That's the key here. How do we solve these? Okay, so I know I'm going to stop here for today. Where we're headed into with the next example, we'll finish this up Monday, is looking at the number of possible roots and then eventually leading into finding roots for higher degree polynomials where maybe these methods don't work